All right, we're going to take a few moments to go over worksheet number 2 that we got on Thursday, writing proportional equations. All right, so on Monday we talked about how to find k. We just take the y value in our table, right? Y is 4, x is 1. And we plug those two numbers in, y over x. So we kind of got to take them and flip them around, because in our table the x is going to be on top, but in our fraction the x has to be on the bottom. So we plug the y value on top, which is 4, over the x value on bottom, which is 1, and we get the fraction 4 over 1. Now whenever we have a 1 on the bottom of our fraction, we can pretend it's not even there, and our answer is just 4. And then once we find what that k value is, we're going to plug it into this equation here. Y is equal to k times x. And we're going to replace the letter k in that formula with the number that we just found for k. So if we find that k is equal to 4, we replace that letter k with a 4, and we get the equation y equals 4x. So let's give it a try with number 2. I'm going to take my first column here. K is equal to y over x. My y value is 8, so that's going to go on top. And my x value is 1, that's going to go on the bottom. Once again, we have a 1 on the bottom. We don't even need it there. We could drop it, and we're left with just 8. So we'll take our formula, y is equal to kx. We'll replace the k with the number 8, and that turns into y equals 8x. And there's our proportional equation. All right, y equals kx. Same kind of thing in number 3. We take that first point. K is equal to y over x. My y value is 5, so that's going to go on top. My x value is 1, that's going to go on bottom. Anything over 1 is just itself, so that top number, 5, is our k. We'll take our formula, y is equal to kx, remove the k, plug in the 5 that we just found, and it turns into y equals 5x. Now number 4 is a little bit different. We're going to follow the same process, but when it comes to simplifying our fraction, we'll see why it's different. K is equal to y over x. My y value is 4. My x value is 2. So now we don't have a 1 on the bottom. We have a 2. There's a couple different ways we could think about doing this. We could just think in our minds, okay, 4 divided by 2, and hopefully we are confident with our multiplication and division facts, and we know that 4 divided by 2 equals 2. But another way that we could simplify any type of fraction is by breaking it up, and we talked about this, I think, on Wednesday. If we break that 4 up, we can ask ourselves, what two numbers multiply to give me 4? That would be 2 times 2. And on the bottom, what two numbers multiply to give me 2? Well, that's just 2 times 1. There's no other way we can split up that 2 into factors, because it's a prime number. So we got 2 times 2 on the top, 2 times 1 on the bottom. We want to find a number that's the same on the top and bottom, so we can cross them out. I see a pair of 2's that will go away. And now we're left with 2 over 1. Well, just like we saw in the first 3 problems, if I have just a 1 on the bottom, I'm going to move this down here, 2 over 1. If we have just a 1 on the bottom, we can get rid of that 1, and all we're left with is 2. All right, so that's kind of the long way of doing it. Again, if we're good with our multiplication facts, we can just figure out that 4 divided by 2 is 2, or we can go bottom to top. 2 goes into 4 2 times. All right, so there's my k. Y is equal to kx. We take out the k, plug in the 2. And there's my equation right there. So I had to do a little bit more work with the simplifying, but that's okay. Now number 5 is also a little bit different. And this is where we always get a little confused because fractions are confusing. We take our y and our x. My y value is 1. My x value is 2. Now, because of what we just went through, you may look at this and go, oh, we just get rid of the 1, and my answer is 2. But that is not correct, because the 1 here is on the top. If our 1 is on the bottom, we can just get rid of it and keep that top number. But if our 1 is on the top, or in general, if we have a smaller number on the top, we want to keep it as a fraction. This is 1/2. So that is my k value. We cannot simplify 1/2. The 1 on top has got to stay on top. So when we plug our k value into our equation, we get y is equal to 1/2 x. It's totally fine for our k to be a fraction. And once we move on to graphing these equations, we'll see what having a fraction as our k actually does to the shape of our graph. Same thing with number 6. I take this first point. K is equal to y over x. My y is 1. My x is 5. I've got a 1 on top, a bigger number on the bottom. I'm going to avoid simplifying because we can't simplify this. My k is just 1/5. So my equation, y is equal to kx, turns into y is equal to 1/5x. Moving on to number 7. This is another interesting one. Y is equal to, got ahead of myself there. K is equal to y over x. I take this first point. Y is equal to 1. X is also equal to 1. Now this is what we call a whole fraction, right? If we have the same number on top and bottom, it's always going to be equal to just the number 1. We could also think of it in this case as we've got a 1 on bottom. We can get rid of that. And the number on top is my answer, and that's 1. So when we go to plug in our formula, y is equal to kx, we get y is equal to 1x. And now the additionally confusing part about this is whenever we have a 1 in front of a variable, we actually don't need to write it. We could remove that 1 and write the equation y equals x. And again, once we get to graphing, we'll see why this is the case. Both of these are acceptable, though. It's not like it's wrong if you put the 1 in front. It's just one of those things about math where you don't really need to write it. In the same way that when our 1 is in the denominator, we don't need to include it in our answer. If we have a 1 in front of our variable, we actually don't need to include it. What this is saying is we have 1x. So if I just have a single x written there, right, that implies that we only have 1x, as opposed to having half of x, or having 5 x's, or 2 x's. That number in front tells me how many x's we have. So if I only have 1x, I can just write a single x, and it means the same exact thing. Moving on to number 8. K is equal to y over x. My y is 15. My x is 5. 5 goes into 15 how many times? Well, that's going to be 3. But we can also split these up. What two numbers multiply to give me 15? Well, that's 5 times 3. And what two numbers multiply to give me 5? That's 5 times 1. We look for the same number on top and bottom that we can cancel. I've got a pair of 5s that go away, leaving me with a 3/1. Again, if the 1's on bottom, we don't need to write it, and we just get 3. Doesn't matter which way you go about finding that. If you're more comfortable splitting it up to simplify, that's great. That'll definitely come in handy once we get into some more complicated things. But if you just know, you can look at this fraction and go, oh, 5 goes into 15 3 times. Boom. K is equal to 3. So we'll plug it into our formula. Y is equal to kx, turns into y is equal to 3x. Just like that. Moving on to the back. Now that we've kind of got our feet wet there with that, I'm going to go through this a little bit quicker. I'm going to take my first point. Y is equal to, I did it again. Sorry about that. K is equal to y over x. Y is 3, x is 1. 3 over 1 is just 3. Plug that into our formula. 3 gets plugged in for k. Y is equal to 3x. Number 10. Take my first 2 points. 10 over 5. 5 goes into 10 2 times, so there's my k. Y is equal to 2x. And I would encourage you to write out the formulas each time, right? Our formula 1, step 1 from our notes, and our second formula, step 2 from our notes. But once you really get comfortable with it, you feel confident in your ability to get it done, you don't need to write the actual formulas each time. Moving on to number 11. K is equal to y over x, which is 7 over 1. Anytime we have a 1 on bottom, we can get rid of it, and my k is 7. There's my equation, y is equal to 7x. Number 12, interesting problem here in number 12. K is equal to y over x. That gives me 2 over 4. And I see right away the smaller numbers on top. As soon as you see that smaller number on top, that should set an alarm off in your brain that we're going to have a fraction answer. I'm going to split this up as much as I can by asking myself what 2 numbers multiply to give me 2. Well, that would be 1 times 2. And what 2 numbers multiply to give me 4? That would be 2 times 2. I've got a pair of 2's on the top and bottom that can cancel out, leaving me with a 1 in the numerator and a 2 in the denominator. We cannot simplify 1/2 anymore. Because the 1's on top, we don't want to just get rid of it. My k value is 1 over 2. There's my equation. Just plug in that k value in for k, leaving the y as y, leaving the x as x. Number 13, y over x. K is equal to 8 over 4. I've got the bigger number on top, so I might not have a fraction here. It's definitely possible to still have a fraction with a larger number on top. It's called an improper fraction, but we'll get to that later. 4 goes into 8 2 times. Y is equal to kx. If my k is 2, then y is equal to 2x. Number 14, y over x. K is equal to 8 over 2. 2 goes into 8 4 times. 2 goes into 8 4 times. So my k is 4. Y is equal to 4x. Number 15, k is equal to 9 over 3. 3 goes into 9 3 times. So y is equal to 3x. And finally, number 16, k is equal to 7 over 7. Oh, I've got the same number on top and bottom. That's called a whole fraction. Right? And a way that we can think about whole fractions, like we said, is if you have a pizza and you divide it into 7 slices. Is that 7? 1, 2, 3, 4, 5, 6, 7. That one's a little bit bigger. So if you got 7 slices, right? 7 slices, and you eat 7 out of the 7, I'm going to shade in the ones that you eat. Right? You ate all 7 pieces. So how much pizza did you eat? You ate 1 whole pizza. 7 over 7 is just 1. So K is equal to, oops, now I did the other way around. Y is equal to Kx. My K is 1. So we can leave our equation like that, or we could drop that 1 off. Like I mentioned on the front, we have 1x. All we need to write is an x. It implies the same thing, that we only have 1x there in our equation. All right? So hopefully that's making some sense. We're going to keep building on this topic over the next 2 weeks. And then when week 4 comes around, we're going to switch to a different topic. But finding K, writing these equations, that's going to be our focus here for the first 3 weeks of the program.